And we did primary cells.
So primary cells, what are the primary cells that you know already? Tell me. They are
Sir, they are the non-rechargeable cells.
non-rechargeable cells. So all of you must have seen the dry cell. Have you seen dry cell? Has everyone seen dry cell? Tell
No,
me
sir,
quickly.
I don't think so.
No, I will show you. Yeah, all of you must have seen the dry cell. Okay. All of you know it. So if you have not seen the dry cell, okay, this is your dry cell, right? Clear?
Yes, sir.
Okay, so this is the positive terminal. Can you see?
Yes, sir.
It's and this is the negative terminal. Okay, how it works? Tell me. Can any one of you tell me?
So it contains a solution and
Yeah.
two types of one anode and cathode.
Yeah, it is non-rechargeable. Okay. So
Converts chemical energy into electrical energy.
chemical energy into electrical energy. That is very true. So what are the compounds? What is anode? So anode is actually your, and who is cathode? That you need to know the, and what is the voltage? You must be knowing it. You must have used. Mohammed, can you tell me? What's the voltage of dry cell, which I have shown you just now? All of you must be using it. Very simple. This is. Yeah.
So I'm
Harshan?
not sure about the voltage.
Yeah, it is dry cell. It is 1.5 volt. Okay.
Yes, sir.
So it is made up of, there are anode and cathode. Okay. Anode actually, it is negative. Okay. Oxidation happening. And it is the container itself act as anode. You can see the negative charge, right? This container is made up of zinc. Do you know that?
Yes, sir.
Everybody? So it is made up of zinc, and this is the positive electrode, right? This is the just now I've shown you in the actual cell. This is a zinc container. And zinc, we started our chapter with this only. We have seen that the zinc is actually has a tendency to lose electrons. Right, this is acting as anode. But who is acting as a cathode? That's what the question is. Can you tell me?
Sir, the positive is the cathode, right?
Yeah, it is the cathode, but what are the ingredients? Have you seen any cell which is broken down after getting used up?
No, sir.
This is the metal cap. Okay, there is a carbon rod. Okay, and there is a black powder inside filled in it. Okay, like this.
So we can't see anything.
You can't see anything.
Sir, your screen is visible to me.
Yeah, you can check your connection. Zed, check your connection maybe.
Yeah, sir.
Or just check whether Arshan, can you see? No background apps are running. Okay, sometimes they take their space. Right? So I hope this is clear. That is zinc cylinder. There is a rod, that is carbon rod. Okay. And what this is a black paste, MnO2 of manganese oxide plus C, and the carbon. And there is a paste of NH4Cl. ammonium chloride, and ZnCl, right? Actually, it is not dry, it is a paste, moist paste, because if it is dry, it can't conduct electricity. That's it. So what is this is, Zaid, is it clear now?
Yes, sir.
Now, I hope you are able to see it, okay? So do let me know if there is any problem. Don't hesitate to stop me, right? So cathode is acting as an acceptor, right? So who is acting as an cathode? MnO2. So MnO2 is actually a black substance. It is mixed with carbon powder, okay, MnO2 solid, and it is accepting 2 electrons. And MnO2, then NH4 plus are there, ammonium ions are there, which are there in the ammonium salt. Okay, you don't need a salt bridge because there is a porous container inside, so that let the iron ammonium ions to move through that porous substance. This is Mn2O3. Okay, this is the balanced equation which I am writing. Mn2O3 and 2 ammonia and water are going to form on the cathode side and anode side. Okay, this is how it works. Is it clear? So
Yes, sir.
normally if you connect these with the help of a wire, the current electricity start flowing, the electrons start flowing through the external circuit, and that's how the cell start working, right? Is it clear?
Yes, sir. Yes, sir.
Everybody?
Clear.
Harshan, Mohammed, Zaid.
Yes, sir.
Okay, sometimes it is of poor quality, so because of if the container is of poor quality, what may happen, that the zinc may get dissolved. Okay, so if the zinc get dissolved, the container may develop holes in it, and that is called leaking of cell. The solution leaks out of the cell. If the container is very thin, if it is of poor quality, the zinc may get dissolved and it may develop holes in it. That is called leaking of cell. Okay, and which cell is used in your other types of equipments? So this was the pencil. This is also known as pencil cell. Okay, this size is known as pencil cell. Okay, what are the other types of cell which are used in electrical equipment? Can you tell me? There is one mercury cell also.
Secondary, sir.
No, this is primary only. The mercury cell. This is known as zinc HGO cell. Right. So a lot of electrical equipment can use this also.
Sir, are you sharing the screen?
Yeah, I'm sharing the screen.
No, sir, it's not visible.
So what about others?
Sir, I can see the screen.
Even I can see the screen.
Yeah, check your background apps and check your network connection. Because just now also I'm having the class of UA students, so they were
Yeah,
also.
sir, I got it.
Yeah, so just check it. Just kill the background app. Okay, that could be the problem. Okay, zinc mercury oxide cell. It is also known as mercury cell. Its voltage is 1.35 volt. Just remember few basic concepts. So this is used in, where it is used? It is used in small electrical devices like hearing aid, watches. Okay, and here also the anode is the compartment, the outer compartment. So zinc actually is very important for us? Anode. It is zinc. Mohammed, can you hear my voice?
Yes.
Okay. So zinc is there. It accepts hydroxide ions, 2 hydroxide ions. It forms zinc oxide. Okay. 1 water molecules formed. And initially zinc was neutral. It was not having charge, but now it is +2 and this is -2. So how it has formed +2? The 2 electrons are released by the zinc. So this is anode. Okay. The negative terminal of this mercury cell. And what is cathode? Tell me. Very simple.
Sir, the positive.
Yeah, the cathode, yeah, that is going to be HgO, right?
Yes, sir.
So HgO solid, yeah, that is a positive. This is the anode, right? And cathode, actually, this is going to be positive. Mercury is that is going to act as an acceptor of these 2 electrons. So mercury will accept 2 electrons. Okay, H2O. And this is going to get reduced to complete Hg. There is the zinc change itself to zinc +2. Mercury was in oxide and mercury got reduced. That changed itself to mercury and 2 hydroxide ions. Okay, if you want to write the balanced equation, that also is very simple. Just add them up. The common things will get cancelled. Zinc plus HgO is going to be ZnO plus Hg. So this can give you 1.35 volt. Okay, it is used in watches. And what about your secondary cell, Mohammed?
So
Can you-
rechargeable.
Yeah, rechargeable. The most common place where all of us needs our secondary cells. Where it is? Where do you use secondary cells of batteries?
In cars.
Yeah, in car, right. Arshin, can you hear my voice?
Yes, sir.
So in car, which battery we use? Can you tell me, all of you?
Sir, secondary cells.
Yeah, and more specifically, it is lead acid batteries, lead acid cell. Okay, right?
Yes, sir.
So how this is, so all of you must have seen it many times. Okay, and it has a lot of compartments in it. Okay, actually we can't see it from outside because it is completely sealed from inside, right? So it is alternate compartment, but outer from the outside we can get the feel of it. There are compartment, it may appear from outside that the compartment are there. Like this one. Okay. So you have cathode and anode compartment. And what's the electrolyte? Can any one of you tell me? It's in the name. Yeah, it is acid H2SO4. Okay. And normally each cell, actually these are cell combined in series. So each cell give 2 volt. So there are 6, okay, 6 of them. So that will give you 12 volt. So most of the car batteries are actually 12 volt. Okay. Right. So these are alternate lead plates and lead oxide plates. Right. So if you have minus, the plus one is going to be PbO2. Right. This is cathode. So why it is acting as a cathode, PbO2, because lead is in +4 oxidation state, it is desperate to take electrons and sulfate. Zaid, are you able to see the screen?
Yes, sir.
Okay, good. I hope the problem is sorted out. Now, so PbSO4. Okay, this is the equation which is happening during discharging. Okay, lead sulfate is going to form, and we are going to get this oxide ions are going to change to water, H2, because there are 2 oxygens. So I will write two water. I need 4 H plus, and lead +4 accepted 2 electron, and that changes to Pb2 plus. Okay. So it is acting as an acceptor. And what is happening on the cathode side, anode side? So anode is losing electron. So if someone want to lose electron, it should not be in positive, because the positive is already formed by loss of electron. Okay, so on the anode actually you have lead. Anushka, is it clear? PBA,
Yes, sir.
or you have lead, and this sulfate actually is formed. It is the source of sulfate is H2SO4. So lead is going to give you 2 electrons. Pb2 plus and SO4, the compound which is formed is SO4 to PbSO4. Okay, the sulfate is going to club with the lead +2 ion, and because you started with lead, so lead is going to release 2 electrons. That's it. These 2 electrons will be accepted by cathode, so you need to connect it. Okay, actually the H2SO4 is slowly getting electrolyzed. This is the reaction, but normally the reaction, so who get oxidized? The lead is getting oxidized, and who is getting reduced? PbO2 is getting reduced. That you should keep in mind. But if you see H2SO4 is just like an electrolyte. It is helping, it is providing ions, H plus ions, sulfate ions, that's it. Is it clear?
Yes, sir. Clear.
So you need to maintain the density of H2SO4, you need to maintain the quality of H2SO4. Otherwise, if the concentration of H2SO4 is too less, then it is the battery is not good, means the battery doesn't have sufficient ions. Okay, you can see over here the ions are required, and the battery is not going to work properly. So H2SO4 which is taken has 38%. Okay, it is 38% by mass, 38% mass percent of H2SO4. Okay, and its density is 1.31 gram per centimeter cube. Suppose if you must have seen somewhere that if you got a chance to, sometimes chance to take your car to for the battery checkup, they check the density of the H2SO4. Okay, they have an instrument to measure the density of H2SO4, and if the density of the H2SO4 fall below this value, the your car battery may not work properly. So you need to replace the solution H2SO4, or you need to replace the complete battery. Okay. So this is actually what is in the electrochemistry part. Just read it, very simple. Now let's move to aldehydes and ketones. Okay. So I hope everybody is doing the assignments which I shared with you,
Yes, sir.
right? So just maintain the continuity, that is very important. Okay. Harshin, Mohammed, Zaid, I hope all of you can see me, right? Abdullah. Yeah, so let's start with a new chapter, aldehyde, ketone, and carboxylic acid, the most important chapter of organic acid chemistry. Okay.
Yes, sir.
So first, recognition of the functional groups. So what are aldehydes? Can any one of you tell me? What are aldehydes?
Carbonyl group attached to a carbon chain.
Carbonyl group attached to carbon chain, very good. Yeah, but you need to be little bit more specific. So you can have hydrogen atoms on both the sides. This is the smallest aldehyde, or at least one hydrogen on the one side, and another side can be carbon atom. This is alkyl group, any alkyl group. Aryl group is a benzene ring. So carbonyl group has either carbon atom or hydrogen atom. Okay. On its either side, at least one hydrogen should be there. Okay, for it to behave like an aldehyde. At least one hydrogen should be there. Other one or both side you need to have hydrogen. Okay, or at least one side you have hydrogen, other side could be an alkyl group like methyl, ethyl, CH3, right? Or ethyl group. You represent alkyl group by R, or you can have some aromatic group like phenyl. Okay, right? Some aromatic
Yes,
group
sir.
called naphthalene. So this is an aldehyde. But remember, very important, very important. You can't have any third atom directly connected to C double bond O. An atom of any third type of element can't be there. Is it clear?
Can you repeat?
Abdullah, is it clear? It means oxygen should not be there. Suppose if someone asks you, is this an aldehyde? If someone asks you, is this an aldehyde? Someone may say, okay, this is also an aldehyde. Look, there is H connected to C double bond O. All these are the characteristics. Actually, most of my students remember this thing. So that's why I am asking you, I'm telling you that you need to have only carbon and hydrogen on both the sides. No third atom. So these are not aldehydes and ketones, right? And not aldehydes, because on the other side, someone may think, okay, there is one H, but that being connected to H, is not the only thing for which you need to look for. You also need to look for that the other side should not be any heteroatom, any atom of any other element, carbon, hydrogen. This is, so all of you must write it. So aldehyde ketone, these are not aldehyde ketone, these are carboxylic acid derivatives. I hope all of you will remember it. These are neither aldehyde nor ketone. So then what are these? Tell me quickly.
Sir, carboxylic
Or
acid.
carboxylic acids.
Carboxylic acid derivative, or this one also. Okay, if you have OH, these are the compound. So this one, lowest one is the carboxylic acid itself. Okay, smallest carboxylic acid. And the upper ones are the compounds which are derived from carboxylic acids. So they are called carboxylic acid derivatives. I hope it is clear.
Yes, sir, clear.
Okay. So carboxylic acid and their derivatives. So this is also a part of this chapter, but you need to differentiate, because most of the people sometimes they say there are two functional groups. This is aldehyde and this is halide, and this is, there's sometimes they say three. Okay, this is aldehyde, this is ketone, and they get confused. Okay, so you need to be very clear. In aldehyde and ketone, there should not be any third atom. If any one of the, so connected to, directly connected to CO, there should not be any third atom of any other element. For aldehyde, it need to have one hydrogen. Abdullah, can you hear my voice?
Yes, sir.
I hope, yeah. So are you getting what I'm trying to say? Aldehydes, okay. There should be one hydrogen, or both side can be hydrogen, but what should be what should be on the other side? Other side should be only carbon or hydrogen. That's it. And what are ketones? Ketones are actually very simple. So you have a carbonyl group, and both side you need to have alkyl groups. The alkyl groups could be same or different. Carbonyl group connected to alkyl groups. On both the sides, that is a ketone. Okay, this could be an aliphatic ketone or an aromatic ketone, that depend upon the nature of the group. If you have some benzene ring, that is aromatic ketone. Okay, clear? So carbonyl group connected to alkyl groups or aryl groups on both the sides makes it a ketone, right? And how do you get carboxylic acid?
Sir, COH.
Yeah, carboxylic acid. Arshin, that is CO. So that's why there is a same chapter. Okay. So if you have carbon and hydrogen atom only, there are other aldehydes or ketones. But on one side, if you have OH, that is carboxylic acid. Carbonyl connected to OH. So don't say these are two functional groups. This is an alcohol and this is a ketone or an aldehyde. No. It may appear, and many students make mistake in this. Don't say that these are two different functional groups. Someone may say, okay, this is an alcohol. Someone may argue that this is an alcohol. Is it an alcohol? No. This whole thing, as a whole is going to react in the same manner. It's not, but when we look at them, it may appear that there is CO and there is OH. Okay, but that is the wrong way, because this CO and OH on the carbon, same carbon atom, makes it a different functional group. Okay, is it clear? So this is a carboxylic acid.
Yes,
Okay,
sir.
So we can write some of the examples of aldehydes. We can write first three aldehydes, and we can write first three ketones, first three carboxylic acids. Okay. So what are the name of the first three simplest aldehydes? Who's going to tell me? Yeah, Mohammed, tell me. Abdullah and Mohammed, tell me quickly. Zaid, what is going to be the name of first three aldehydes? Yeah. So aldehyde, if you have an aldehyde, you write word root and the suffix, you write "-ane", "-ene" or "-ine", and you write suffix "-al", right? Clear? For aldehyde it is "-al". So now can you tell me, Arshin, what's the name of the smallest aldehyde? How many carbon atom are there? Smallest aldehyde. Z, what's the name of the smallest aldehyde? Mohammed, yeah, tell me. So you have one carbon atom. What's the word root for one carbon atom? That is meth. And if you have one carbon atom, that is, and there is no double bond between the carbon atom, because there is one carbon atom, there should not be any
Carbonyl. Sorry, methanol.
methane, right? Yeah. And methane, and if it is an aldehyde, you are going to put "-al", right? Methanol. Okay. Is it clear? Abdullah?
Yes, sir, clear.
Right, very good. So this is going to be methanol. And what's going to be, Arshin, the next one? This is methanol. And there are two carbon atoms. So what's going to be the name of this compound? Who will help me out? Yeah, tell me.
Ethanol.
Yeah, carbon-carbon bond are single. Okay, this "-ane", and you will remove E because you don't write two vowels together. "-al" starting from A, so you're going to drop the E, ethanol. And what's going to be the name for this one? A three carbon atom.
Phenol.
Sir, butanol.
Yeah, no, three carbon atom, prop.
Propanol, sir, sorry.
Yeah, propane, propane, and I'm going to drop the E. Okay. Is it clear?
Yes, sir.
Propanol, right. Similarly, we can write the name for first three ketones or some ketones. I hope all of you can do it. Okay, let me write some ketones. Smallest ketone is the one which need to have three carbon atom, because you need to have a CO, Arshin, Z, and you need to have carbon on both the side to become a smallest ketone. So how many carbon atom are there? Carbon atoms are there?
Sir, 3.
Yeah, 3. So what's the word root for 3?
Prop.
Yeah, prop. And is there a double bond?
No, sir, only single bond.
Yeah, between carbon. Don't look at this one. Okay, between carbon there is no. So propane.
Sir, the suffix for this will be "-one", right?
Yeah, ketone suffix will be "-one", so that also is a vowel. So I'm going to remove "-one", propanone. Okay.
Yes, sir.
So suppose if you have 4 carbon atoms, so that is going to be this one. So where should I put the double bond O? Can I put it in the at the extremity on the terminal carbon atom, or do I need to put it in the middle to get ketone?
Sir, in the middle, right?
Yeah, in the middle, because otherwise what will happen if I put it like this? Abdullah, can you hear me? Zaid, this is going to become an aldehyde. Okay, this is aldehyde. That one will be butanol. And this is butanone. Butane, or if you need to write completely, but 2 is not required here, butanone. Okay. What about this one? Which ketone is this? Tell me quickly.
Pentanone.
This is
Pentanone.
5 carbon atom pent. But here it is compulsory to write the locate. Why? Pentane. Should I write it 2? Because 2 also is ketone and 3 also is ketone.
Yes, sir.
So what? But in butanone it was okay. But in pentanone it is very, very important to write. So what should I write?
Pentane 3 on.
Yeah, pentane 3 on.
Sir, why did we not mention the location in butanone, and we mentioned
Yeah,
the
you can, but there only one butanone is this butanone. Actually, you need to have it in the middle. You can't have any 2 positions. So if there is no ambiguity, you can skip the locate.
Yes, sir.
But if there is, suppose in the case of pentanone, there was ambiguity because there are 2 types of pentanone which can form on 2 on 3. Okay,
Yes, sir.
clear. So that's why. So if there is ambiguity, you are not going to skip the locant. That is compulsory. Okay. So now we will practice some of the IUPAC names. Very, very important.
Examples for carboxylic acid.
Carboxylic acid, because we are going to have a separate discussion for carboxylic acid and all the derivatives and their nomenclature and their preparation, everything. So we are going to we will study aldehyde and ketones together and carboxylic acid and their derivatives together in terms of reaction, nomenclature, everything. So this chapter I will divide it into 2. Is it clear?
Yes, sir.
Otherwise it is if I mix them up, it is going to be easier for me but difficult for you to remember and understand. Okay, that's why we will divide it into aldehyde ketone. Okay, this is the first segment, and the second segment is going to be the carboxylic acid and its derivatives. Okay, so let me write. So you can tell me the IUPAC names. As of now, we are limiting our discussion to aldehydes and ketones only. And there are some common names also. The common name being very common, so for some, not for all. You need to mention it. Okay. So write the IUPAC name of the following aldehydes and ketones. Arsin, can you hear my voice? Zaid, Mohammed, Abdullah.
Yes, sir.
Yes, sir.
So what are the IUPAC names of these compounds? You also need to tell me whether it is an aldehyde or a ketone. Yeah. So for the first one, is it an aldehyde or a ketone?
Sir, aldehyde.
Yeah, aldehyde. You have one hydrogen on one side, another side you have an alkyl group. Alkyl group, these are the carbon atoms. Okay, because it is bond line representation. If you want to write it in the complete form, it is going to be like this. So you need to select the longest continuous carbon chain. And what that longest continuous carbon chain, how many carbon atoms are there in it?
Sir, 3.
3 carbon atom. Total it has 5 carbon atom. Okay. So 3 carbon atom in the longest continuous carbon chain. You need to do the numbering of the chain from one end to another, starting from the functional group, so that you get the starting from the end, so that the functional group get the lowest locant, lowest number. So I started from C double bond. I hope everybody can see this. Okay.
Yes, sir.
And this is propanol. Okay, this portion, propanol. So this is the word root, primary suffix and the secondary suffix. Okay. But whatever is not included in the name, so where it finds is its place in the name.
Sir, in the beginning.
Yeah, in the beginning. So before the word root. So just like we have preface in the books. So in the name we have prefixes. Okay. So what are the prefixes? Zaid, Muhammad, Abdullah, Arshin, Anushka. What will be the prefixes in this case? So I have written only the name of this part.
Methanol, dimethyl.
Yeah, dimethyl, and where it is located, you need to tell the locant.
2,
For
2,
each one
2
of
dimethyl propanol.
2, 2 dimethyl. Yeah, dimethyl propanol. Correct?
Yes,
Okay.
sir.
Okay, I will complicate this so that you can. What's the IUPAC name of this? This is an aldehyde or a ketone?
Sir, aldehyde.
Yeah, this is an aldehyde. Again, this is an aldehyde. Okay, and what will be the name?
Sir, in this 4 carbon atoms are present.
Yeah. So word root is going to be?
Propanol.
No, word root for 4 is but.
Butanol.
Yeah,
Butene.
yeah. It is going to be but. Okay, that's the word root. And should I put in or ein? If there is a single bond, all bonds are single between the carbon in. If there is one double bond, so I need to put in. Okay, but in. But also
Should
I
we mention the position?
yeah, definitely we need to mention where that in is, because it is as 2, so but 2 in. Okay, and aldehyde but 2 enol. Okay, one null, but that is for sure. Okay, but 2 in ene, but I'm going to skip that e. Okay, I will write it and then cut it so that you can see it clearly. Null, but 2 enol. That's going to be the IUPAC name of this, right? I hope all of you can see it clearly.
Yes, sir.
Good. And what's going to be the name for this one? Tell me. So which is the parent chain? So for that, I should say the parent chain is the one longest continuous carbon chain which contain the principal function.
Benzene ring.
Yeah, this is not benzene. Yeah, it looks like benzene,
Yeah.
but this is cyclohexane, right? This is the parent chain, correct? So first we need to, so this is the parent chain, and how many carbon atom are there? So 6 carbon atom, hex in, okay. But it is not an open chain. It is a ring. So it is cyclic ring.
Cyclohexane.
Yeah, cyclohexane. And what's the suffix? In one
Methyl
is,
4-dimethyl.
and those are the prefixes. Hexane, what the suffix of the main function?
Al.
Al or on?
On.
Sir, own.
Yeah, you need to look on the both side. It is having the carbon atom. There's no H. So hexane on. I have removed that E. Just check it. Hexane on. Okay. And where the, so now rest of the part are come in prefixes. So prefixes are, so I need to do the numbering from the principal function group 1, 2, 3, 4. Okay, so where you on the 3
Methyl 4-dimethyl.
yeah, 3 methyl and 4 you have ethyl. Okay, this is the part, this is similar to ethane. So ethyl and 3 methyl, 4 ethyl. Irrespective of the locant, you need to write them in alphabetical sequence. So 4 ethyl, because E comes before M.
Sir, how do we write dimethyl in this ring?
Yeah, just I will give you the example. Yeah. Good question. So 4 ethyl, 3 methyl cyclohexanol. Is it clear? All of you, Arshan, are you getting it?
Yes, sir.
So what's the name for this compound? Yeah.
2,6 di.
Aldehyde, right?
Yeah, 1, 2, 3. I will do the numbering.
2,6
Hmm.
di.
Yeah. How many wings are there? How many branches are there?
2,6 dimethyl.
4 branches. 4. Just look at them. You are partially correct that at 2 places you are having. Okay, but how many branches are there?
4 branches are there.
Yeah, 4 branches. That is clear to everybody. Arshan, Abdullah.
Yes, sir.
Yes, sir.
Okay. Mohammed, is it clear? So 4
Yes.
branches. So I started the numbering from double bond O ketone, right? So that name is same. This portion is exactly same as above. This is cyclohexanol. And you have 4 branches, so each one, so 2, 2, 6, 6. There are 4, so tetramethyl. Cyclohexanol. Clear? I hope it is clear to everyone. Any doubts in this? Let's do this one. These are from NCERT. Yeah.
So in the previous example,
Hmm.
it will be an aldehyde and not a ketone, right? Because it has got carbon atom on both the sides.
Where? This one.
Sir, on the 4 branches.
This is ketone. Yeah. So I've written on. Correct. Absolutely correct.
No, sir, I was saying that will be an aldehyde, right?
No, actually, because it is like this. It see double bond O is there, and it is connected to the carbon atom of the ring. And here the 4 methyl groups are connected. So this carbon is connected to carbon atom on both the sides. Okay.
Yes, sir.
So this is a ketone. That's why I have put on. Right?
Yes, sir, I understand.
Okay, good. So this is, so what is your important task? Okay, there is a table given in NCERT and its table is 12.1. Okay, this table is so important, so basic. It is because it is given in NCERT, so it is very basic, but it is so important that the questions from this table come in JEE and NEET examination. Okay, this is a very nice table. So I always ask my student to go through this table. There is a set of common names given and the IUPAC name. Very important, small table, NCERT. So all of you will, I hope, go through this table. Is it clear? Everybody understood what I'm trying to say, what I'm trying to speak?
Yes, sir.
Yes, sir.
Table 12.1, and it is so important. And when my JEE students come and ask me, okay, sir, from where this question has come, so I ask them, okay, this is right, this is nowhere from a fancy book or from which is from the US author or UK author. Okay, this is right from your NCERT book. Okay,
Yes,
this is
sir.
table 12.1. So always, so everybody, all of you after today's class will go through table 12.1, the common name and the IUPAC name. Both are listed. Structures are also given. Just you need to write them on your own so that you have the confidence. Okay, of aldehydes and ketones.
Yes, sir. Sir,
Yeah.
sir, for the preparation of this board examination,
Yeah.
referring to NCERT will be enough for any other reference book we need to look as well.
NCERT is enough, or you can download your. Though we are covering in detail, but if you want to do some more questions, you can have previous. So all of you need to have previous year papers.
Yes, sir.
Okay.
The OSWAL is good, right?
Yeah, anyone you can take.
Sir, I have OSWAL and exam idea.
Yeah, good.
Yes.
And the next thing is previous year papers you need to have. Another thing is you need to practice daily. Okay, now the practice should be more, a little bit more frequent. Okay, in a balanced way.
Yes, sir.
For all the subjects. Okay, you need to write very clearly what is the thing which is being asked. Don't over exaggerate or write too much or write too less. Whatever is asked, write to the point. Be clear in whatever you are writing and you will get full score. That's what I say to all of my CBSE students, and they score really well. Okay, if they
Yes, sir.
practice. So I hope all of you will follow this procedure. Okay, what's the name for this? You can have that exemplar also, questions from exemplar that you can download.
Yes, sir.
So that also has some theory questions, good theory questions. So this this is an aldehyde or a ketone?
Sir, aldehyde.
Aldehyde.
Yeah, this is an aldehyde, right? So because one side you have, so what's the name? Here it is having a problem. You need to be very cautious in this. Actually, suppose if you have a functional group connected to, directly connected to a cyclic ring outside cyclic ring, then there is a special type of suffix which is being used. Okay, and that is cyclo. This is the parent chain is cyclohexane.
Cyclohexanol.
Hexanone is ketone.
Hexanol.
Hexanol is alcohol. That is single bond OH.
Cyclohexanol.
But cyclohexanol, okay, this is cyclohexanol, and cyclohexanol will, if you write, that will says, if someone read it, okay, that will imagine, oh, this will have 6 carbon because you have written cyclohexanol. But can you see here there are 7 carbon atoms, not 6.
Yes, sir.
So this is some ambiguous case. Whenever you have a functional group directly connected to cyclic chain, directly connected. If it is not directly connected, then you are going to follow the standard procedure which we discussed earlier. Okay, so directly
Cycloheptanol.
heptanone, again that is a problem.
Sir, heptanol.
Yeah. Suppose if someone says cycloheptanol, aldehyde, this is aldehyde. Okay, so suppose if someone read, then also it will have problem. That person may say cycloheptane means ring of 7 carbon atom. What you thought is correct. Okay, but the person who will read cycloheptanol, the name indicate that cycloheptane means ring of 7 carbon atom and aldehyde, right?
Yes, sir.
Ring of 7 carbon.
Cyclohexane 1-all.
Yeah, something like that. So, but you need to cyclohexane, but you need to have the information of the carbon. So there is, let me write it. It is carbaldehyde. Cyclohexane carbaldehyde. This is not good. This suffix you are not going to use anywhere. Just only if and only if you have the aldehyde group directly outside the ring, cyclic ring, then only. Is it clear? So this is, everybody make mistake in this. So very,
Yes,
very
sir.
important. This is there in your NCRT. Okay.
Yes, sir.
Very important. But everybody goes wrong in this. Okay. So no need to worry. Everybody. Zed, is it clear? Abdullah, Arshad. Right. And what's going to be the name for this one? This is a very, very common aldehyde.
Sir, that's an aldehyde as well, right?
Yeah, that is, there is a common name also. This is benzene and aldehyde, benzaldehyde.
Benzaldehyde.
So where do we see benzaldehyde?
Sir, I guess some medicines.
Yeah, in medicines it is used. Yeah. Benzaldehyde is there. This is the common name, but this is so common that IUPACs also absorbed it. So you can write benzaldehyde. Okay. But if someone goes very strictly as per IUPAC name, so this was the common name as well as IUPAC name. But if someone goes very strictly as per IUPAC name, so you are going to follow the above procedure. So benzene, carbaldehyde. The same strategy you are going to follow here, because this aldehyde is directly connected to benzene. Though both, in this case, both coexist. Is it clear?
Sir,
Yeah.
sir, I have a doubt. Sir, if we see the structure of the two, if we see the two structures, the first one and the benzene
Yeah. Tell me.
one, they look similar, right? So why
Very
are they
similar. The
named?
difference is of the double bond. The benzene has 3 alternate double bonds located inside them. The upper ring is cyclohexane that is completely saturated. There were no double bonds, just single bond, all bond one single within the ring. The
Yes, sir.
benzene has double bond, single bond, double bond, single bond, like that. Okay.
Yes, sir.
Three. That's what the difference is. Okay. So what's the name of this?
Sir, that's an aldehyde as well.
Yeah. So that's the main group that is same a derivative of the above compound 4-nitrobenzaldehyde. Benzaldehyde is also acceptable. Or if someone goes strictly as per IUPAC name, you can write 4-nitrobenzene carbaldehyde. Benzene 1-carbaldehyde, okay, if you want. One is often omitted if there is no ambiguity.
Sir,
Is it-
how 4-nitro?
Because you need to start the numbering from the position where the principal functional group is connected. Okay.
Yes, sir.
So I started the numbering from this carbon because aldehyde is the main group that decides that from where the numbering should get started. Okay, so let me give you the last examples of nomenclature. Okay, so and the common names are also very important. The common names are absorbed by IUPAC name. So this is benzaldehyde. That's what we have seen. I hope everybody will remember it.
Yes, sir.
This is an aromatic aldehyde. Okay, because there is one aromatic ring connected to it. And this is a ketone. Because you have carbon groups on both sides of C double bond, but one is aliphatic, another is your benzene, and its common name is acetophenone. This is very common. You can't afford to forget it. Okay, acetophenone, and this is common. The IUPAC name is going to be. This is the parent chain now. Okay, ketone. Clear? So IUPAC name is going to be your 1-phenyl ethanol. And there is one more, which is also very common, and there is a common name also being very common. So this is completely aromatic ketone. The two aromatic rings are connected on both the sides. Its name is benzophenone. I hope everybody will remember this. And the name is diphenyl methanol. This is a ketone. So this is the parent chain. The parent chain is none other than the carbon itself. Okay. Is it clear?
Sir, there is formaldehyde as well, right?
Formaldehyde, yeah, that is an aliphatic.
Yes, sir.
All the list is given. Okay, in table 12.1. So all of you should try table 12.1 from NCERT. You will write on your own. You will just see the structure. Okay, but common name you can't predict. You can see the common name, but IUPAC name you should first try it. Okay, then check your answer. Okay, and then whether you are able to find it out or not, and if not, you can take my help. Okay, and but I hope you will be able to do it, right? And you can try it. Okay,
Yes, sir.
so now the reactions and preparation. There are two things in every chapter: organic chemistry. Okay, first we need to think how we need to prepare those compounds. Abdullah. Okay, Arshan, Zaid, and the next thing which we need to know is how to prepare those compounds and what are the chemical reactions. Okay, every chapter is like this only, the layout of every chapter. Okay, so first is the preparation. Okay, on Monday we are having the test. Okay, which was, I hope everybody remember it.
Yes, sir.
Okay, so be prepared for it. 35 marks, 1.5 hour. Okay, just try it. Right? So preparation. So how you are going to prepare aldehyde and ketone? Who is going to tell me?
Alcohols.
Yeah. So aldehyde ketone contain oxygen, doubly bonded oxygen. So you can start with alcohols. How? From alcohols by what? You need to add hydrogen to alcohol or remove hydrogen to alcohols from alcohols.
Sir, add.
Suppose these are the alcohols, OH. Okay. This is an alcohol. Okay. And what we need to do to get aldehyde or a ketone?
Sir,
Doubly-
remove. Sir, remove the H from the alcohol.
Dehydrogenation.
Yeah, dehydrogenation, but removal of H is also known as oxidation. Right?
Yes, sir.
Oxidation of alcohols will give you aldehydes and ketones. Whether it is an aldehyde, whether it is a ketone, it depends upon the alcohol itself, which you have taken, right? So I will get into the detail of this. And the other thing is, suppose if you have a primary alcohol, some carbon containing group CH2OH. So primary alcohol, if you do the oxidation, what you are going to get?
On oxidation.
Yeah,
RCHO.
R, yeah,
CH2O.
C, there is one H
CR.
removed. Yeah, one H removed from carbon, one H removed from oxygen. Okay, is it clear? But actually, there is one thing which you need to remember, that is you need to do the mild oxidation. So you need to take the agents accordingly. Mild oxidizing agent, primary alcohol, 1 degree alcohol. Okay, what are the mild oxidizing agents? PCC, pyridinium chlorochromate. Okay, or I'm writing or, means anyone, don't take all of them. Copper red hot tube, or pyridinium chlorochromate, which is a very good mild oxidizing agent, and someone may write it PCC, someone may give you and write the formula. This is the formula, but normally formula doesn't come. Okay, you don't have to take strong, because if you go for strong oxidizing agent, what may happen is that you may end up with carboxylic acids. Okay, what about secondary alcohols? Arshin, Zaid, Abdullah, tell me quickly. What about secondary alcohol? Secondary alcohol is the alcohol whose carbon is on which the OH is present is connected to 2 alkyl group. Yeah.
Sir,
Yeah.
sir, this next Monday and Wednesday, that is 14th of November and 17th of November, I
Yeah.
won't be able to join the class, sir, because at that time I'll be having my exam.
Okay. Okay.
So, sir, where can I find the recorded class?
Yeah, you can contact with the class mentor. Okay, they will help you out. Okay.
Okay, sir.
Or what you can do is you can just log in and start the recording on your laptop.
Yes, sir.
You can start the screen recording on the laptop, so you also can do that. Okay.
Yes, sir. Thank you.
Right. Yeah. So this is secondary alcohol, 2 degree alcohol, and this also can be oxidized, but here you don't have to worry about the mild or strong, because secondary alcohol they get oxidized to ketone. Okay, so how do you prepare ketone? This is the solvent which is used to dissolve. Okay, so I hope this is clear. Oxidation, but which alcohol do not get oxidized easily? Okay, why they do not get oxidized easily? Tell me quickly. What's the
Sir,
reason?
because of their bonds.
Yeah, Yeah, or you need to be very specific, Arshan, Z.
Hydrogen bonds, sir.
Yeah, more precisely, where you have hydrogen and where you don't have hydrogen. That you need to tell me.
Sir, on the carbon atom.
Yeah, on the carbon atom, there are no hydrogen. Okay.
Yes.
So it is very difficult to oxidize them under normal condition. Is it clear?
Yes, sir, clear.
Right. So they are not going to be used by us for the preparation of aldehydes and ketones. So just remember aldehydes, primary alcohol, ketones, secondary alcohol. But primary alcohol, you have to be careful because if you take KMNO4, if you take potassium dichromate, they are going to end up give you carboxylic acids. Abdullah, is it clear? Arshan, Zad, I hope you understood
Yes,
this.
sir.
Yeah, very, very important thing. Tertiary alcohol, actually, normally they don't get oxidized under normal condition, but if you heat them strongly, they will give you carboxylic acid mixtures. Okay. So you're not going to use tertiary alcohol, just primary and secondary alcohol. So that's the way by which you can get aldehydes and ketones. Is it clear? And another thing is, what are the other ways by which you can get aldehydes and ketones? Let me be very precise. Preparation of, so though we are going to do it in the on the next turn, but let next turn is test. Okay, so whenever we have the class, so next preparation of aldehyde and ketones from alkenes. You need to say me just one word. I need to hear just one word.